about weathering and part of weathering and erosion. So there are two types of weathering. First, you have physical and chemical. The one we're going to look at first right now is physical, and then we'll look at chemical in a second. So physical weathering is also considered mechanical weathering or mechanical breakdown. And it's the breakdown of rocks caused by things like weather, changes in temperature, moving water. Any of that causes a physical change like the size and the shape. Typically, they get smaller. And one of the simplest forms of physical weathering is where rocks get heated, then cooled, which makes cracks, and then water gets into those cracks, it freezes and expands, and then it breaks the rock apart even further. This is called frost action or frost wedging. And you can see it here in this little GIF where the water got in, it froze, it expanded, and it ended up breaking the rock away. Another example of physical weathering is called abrasion. Please highlight, star something. This is one of those words that the Regents loves to ask, and it's a really good vocab word to understand. So abrasion is just where rock rubs against another rock, which causes both rocks to become round and smooth, or at least the one that's moving to become round and smooth. This happens frequently in streams, rivers, when waves are present in large lakes or oceans. So if you've ever gone up to Oswego County, next to Oswego, SUNY Oswego, there's a place called Rudy's. It literally has a beach that looks basically just like this. It's all rounded rocks. It's where people love to go skipping rocks. And that's because the waves do come in and push all these rocks against rocks. You can hear it, and walking on it, you can hear it. It's the rubbing, the abrasion going on. So the climate that you want to have for physical weathering to occur is you need the temperature to go below and above freezing, and there has to be moisture. There has to be some type of water involved. So you have above and below that gets the freezing, and even here, there has to be water for it to move. We will get to another one a little bit later, but it's like frozen water. So even if it's frozen water, that can happen. Any type of water, there's going to be some type of moisture involved in the atmosphere. Now looking at chemical weathering. So I don't like the term erosion right here. It is the change or disintegration of rocks caused by a chemical process. Chemical process means you make something new when it occurs. And yes, something new has occurred. Disintegration, bubbling, any of those. So one of the best chemicals in Mother Nature is called carbonic acid. You actually make this when you breathe out because it's just a combination of carbon dioxide and water, which is what you're breathing out. But if you remember from the Rocks and Minerals Unit 2 in the minerals on page 16, there's a mineral or two that are susceptible to acids or bubble with acid. The one we're going to really look at is calcite. The other one is dolomite. And if you look at page 7 of your reference table, in the metamorphic section, you're going to find the rock, the metamorphic rock, that is also susceptible because it's got calcite in it or is made of calcite. And that would be marble. Marble gravestones, like you see right here, the older ones in cemeteries, are affected by carbonic acid and sulfuric acid from the acid rain. Sulfuric acid you're going to get from a lot of the plants burning stuff, coal plants burning. That's going to give the sulfuric acid in the air, sulfuric acid that turns into acid rain that comes down. And this rain goes and it travels through the earth because remember, it goes down until it hits impermeable rock. So it keeps on going down. It infiltrates until then. But when you have our lovely little marble headstones, because it is not going any farther down, all that acid rain, it touches those marble stones and it dissolves away lettering, numbers, faces, and stuff like that. Like the Pantheon has marble sculptures that have been disintegrated as the years come, partially due to acid rain, and we'll get to the other part later. Calcite is also in a sedimentary rock. That sedimentary rock is limestone, which, like I said, all this acid rain keeps going down and down and down, and when it hits the limestone, it starts to bubble and disintegrate, and that forms caves. Chemical weathering, the atmosphere you need for chemical weathering is it's got to be hot and humid, hot and moist in the atmosphere. One last thing about weathering. A big thing is surface area. The amount of surface area or amount of the area that can touch whatever weathering is going on determines how fast that rock is weathering. The greater the surface area, the faster it weathers. Meaning, right here, this has small surface area. Even though it's big, it's small surface area. Why? Well, here's a sugar cube. The only thing, if I plunk this into my coffee, the only thing that touches the coffee or the water part is the stuff on the outside. So this has a small surface area. Whereas if I crush this up and I get my packets of sugar, which is a crushed up version of this, if I pour this into my coffee, this dissolves so fast because all of those little cubes are touching the water at the same time. But all these little cubes, if I put them together, make this. So the difference is this has great surface area. There's more of it. It's like a powder form. Whereas this is not. This, the inside parts don't touch the water, so it can't dissolve. It has to wait until the outside parts dissolve first. So for weathering to occur, if you want to weather the whole thing, it's better to have it broken up than it is to have it whole. So the more broken it is, the faster it can weather. All right, that is it for the notes. If you have any questions, don't hesitate to ask, and I hope you guys have a great day.